This is Algebra 2 with Trig, Unit 5A, the review. Here for the first one, we want to write it with exponents. So because it's a radical, it's going to be a fractional exponent known as rational exponents. The index is the denominator, and the whole thing is to the first power, so it's 13 to the 1/4. Here our index is 3. So the negative 12 is being affected by the whole cube root, and which is being affected by the 5. So it's 5 over 3. Now we'll do this one in the reverse order. We'll write it in rational notation. That means we're going to use a radical with the 44 on the inside. Because the exponent has a denominator of 6, the index is a 6. Here, our denominator is a 5. The negative 28 is inside the parentheses, being affected by the rational exponent. So it goes inside the radical. Now you can place the 7 on the inside of the radical, or you can place the 7 on the outside of the radical. So here we're going to evaluate. We're not using any calculators for this. What I notice is that 81 is to the 4th power of 3. We have a power table. If you look under the 4th root, you come down to 81. You notice that the 4th root of 81 is 3. So we have 3 squared, which is going to be 9. Over here, we have the negative 8. It's being affected by the denominator. Now we could write this in radical form. We could call it the cube root of negative 8. That would be just fine, but you don't have to. If you know that the 1/3 power means the cubed root, then this is the cubed root of negative 8, which is negative 2. And we are squaring negative 2. So we get 4. The cubed root of 125, using our table of powers, we look under the cube and work backwards to figure out the cubed root of 125 is 5. So we know that we have 5 to the negative 2 power, because the cube root of 125 is 5. The negative tells us that we're going to place the 5 in the denominator with a positive exponent, which 5 squared is 25. Here's our rational exponent. Because there's no negative involved, I don't have to have extra parentheses. The 1/2 is working with the 16, so it's the same thing as the square root of 16, which we all know is 4. So 4 cubed is 64. This is the cube root of negative 8, which is negative 2. Because a negative 2 times a negative 2 times a negative 2 makes negative 8. Here we have 216 to the 1/3 power, and we'll put this -2, we'll put that on the outside. So we're trying to calculate what is the cubed root of 216. So we go to the cube, we go down to 216, and we notice that that is 6. So 6 with an exponent of -2. The negative exponent means put it into the denominator with a positive exponent, 1/36. When we're multiplying, we can multiply these by putting them all underneath the same radical. 16 is broken down into 4 times 4. So the cubed root implies that you want 4 of the same number. Another way to look at this is 64. The cubed root of 64 is 4. Here we have 2 radicals with the same index. That means we can write these as one big fraction. So you can divide. And looking at our table of powers, we look under the 5th root down to 32, and we see that that's 2. So the 5th root of 32 is 2, meaning that 5 times 5, 2 times 2 times 2 times 2 times 2, 5 different 2's, multiply together to be 32. Here, to add 2 radicals, we need the radical to be exactly the same. You gotta have like terms. So we need to break down 625, looking for 3's of a kind. So the type of numbers you want to use are numbers that fall under either your cube, so either 8, 27, 64, 125. One of these numbers is what we want to hopefully go into 625. And of course, 125 times 5 is what makes 625. So nothing I can do here. The cube root of 125 is 5. That's why we chose it. You still have the 5 that's on the inside. So this is 6 cube root of 5 plus 4 times 5, which is 20. Cube root of 5. So now we're adding like terms. So 6 and 20 is 26. X cubed. Sorry, 26, the cube root of 5. So we'll do the same thing here. So if you can, pause the video, come back, check it out. So we're talking about cube roots. So that means you want to look under the cube column again, and you work your way down. You get to 27. Well, 27 times 4 that makes 108. If you didn't know that, you could take your 108, break it down. You know that a 2 goes into that evenly. You know that a 2 goes into that evenly. And there's your 4 times 27. Cube root is, or 27 is a perfect cube. So we have 3 cube root of 4 plus the 1 cubed root of 4 gives us 4 cubed root of 4. Like we did before, if you can pause the video, give it a try, see how you can make number 12 and number 15 similar. We're going to write it with one big exponent. This is the cube root. 3 goes into 19 6 times with 1 left over. Goes into 12 4 times. So this is the cube root of 64. And we've learned that that is 4. Because 4 times 4 times 4 makes 64. We're subtracting. So we need our radicals to be exactly the same. They're not the same. 5 doesn't break down. So 3 to the 5th power times the cube root of 5 isn't going to change. But 40 is made up of 8 times 5. And 8 is a perfect cube. We want to use numbers that are in the cube root column. 27 doesn't go into 40. Obviously 64 doesn't fit into 40. But 8 does. And we also notice that the 5s will be left over. So the cubed root of 8 is 2. So this is going to be the same. Minus 1 over 5, the cube root is 2, and then you have the cube root of 5. The cube root of 8 is 2. When you multiply, you only multiply the top of the fraction, and the bottom of the fractions go together. So we have 3/5 times the cube root of 5 minus 2/5 times the cube root of 5. Now we see that the like terms are the same. So 3/5 minus 1/5, 3/5 minus 2/5 gives us 1/5. Cube root of 5. You've got to be sure to include the correct index for your final answer. Here we're going to be simplifying. You notice we have A's, we have B's, and C's. So when you have a fraction, you can subtract the exponents. So this becomes A, 3 minus 5/6, B, 1 minus a negative 3/4, and C, 1/2 minus 2/7. For us to be able to combine these fractions, we need to be sure to have common denominators. So with the A's, those exponents need to have common denominators. Of course, they're both going to need to be 6. So this one is 5/6. If 3 is going to have a denominator of 6, then it has to be 18 over 6. That's the same value of 3. B has an exponent of 1. It has to have the same denominator as the 4. So it's going to have 4 over 4, because that's a value of 1. That has a denominator of 4. When you're subtracting a negative, you're adding 3/4. And then C, this is 7. So of course 2 and 7 go into 14. So we're going to have to multiply the denominator by 7 to get to 14. So we're going to have to multiply the top by 7, the bottom by 2. So the top by 2. Now we're ready to simplify. So this is A to the 13/12, B to the 7/4, and c to the 3/14. Cube root. Can 375 be broken down by numbers that are in the column of n cubed? 125 goes into 375. We have a to the 15th, b squared, and c to the 7th. So the cubed root of 125, we know that by looking at the table, that's 5. Not going to be able to do anything with the 3, that's going to be left inside. 3 goes into 15. There are 5 groups of 3 of a kind, because 3 goes into 15 5 times. So it's a to the 5th is going to be pulled out. Can't go into b squared because there's only 2 different b's in there. There's not 3 of a kind. 3 goes into 7, 6, or it goes into 6. So it goes in there 2 times. If you had 7 c's, you would have a group of 3. You would have another group of 3. 3 goes into 7 2 times. So we have c squared. That's the 2 times. What haven't we taken the cube root of? We didn't take the cube root of the 3. We took the cube root of all the a's. We didn't take the cube root of any of the b's. And we had 1 c left over. C to the 1st power. This is the 4th root. So we're looking for 4 of a kind. So what number works with 4 of a kind? 16. Does 16 go into 32? 81 clearly doesn't. So for 4 of a kind, 2 times 2 times 2 times 2 makes 16. So 16 is made up of 2 times 2 times 2 times 2, and another 2 makes it become 32. We don't have 4 of a kind of the x's. We do for the y's, and we have several for the z's. So maybe you want to pause the video, see if you can simplify this correctly, see if you're understanding what steps we've been taking, then play it again to watch it get done. So the 4th root of 16 is 2 we talked about. You can't take the 4th root of just a prime number. X squared, there's not 4 of a kind. But there are 4 of a kind at 6. 4 goes into 6 1 time, so we're going to have y to the 1st power with 2 left over. 4 goes into 12 3 times. There are 3 groups of 4 of a kind in the 12. So there's a 2 we didn't use, x squared. There's 2 more y's left over. But there's no more z's left over. I didn't get the z in there, did I? So that's going to go in there 3 times. So this is 14 y z cubed, the 4th root of 2x squared y squared. Here we're subtracting. To subtract, we need the same exact radical. So this one looks like it might be able to be broken down. If there's no index number, that implies that it's a 2. This is a square root. We're looking for 2 of a kind. So we're going to take the square root of 9. We know the square root of 9 is 3. There are 3 different x's out here. We're going to take 2 of those and bring one of those out. There's already 1 out here. So now that's going to bring a second 1 out. That's going to leave a single x left inside. Minus, we have a 2. Now this is 5 different x's. If you had 5 different x's, and you're doing square roots, so you're looking for pairs of the same, you have 2 different sets, so that's your x squared, 2 different sets, and you have an x left over. So now you see the radicals are exactly the same. You have 3x squared minus 2x squared leaves you with 1x squared. In this case, we can't divide h into g, so it might be best to write this as g to the 19th and the 7th root of h to the 7th. So we're going to break this into 2 radicals. 7 is going to go into 19. We're going to look for groups of 7 of a kind. It goes in there a full 2 times. So we're going to have g squared. We're also going to have some leftover. We're going to have 5 of them left over because 7 goes into 19 2 times, which is 14. And you need 5 more to get up to 19. So you could say that we took out 14 of the g's in groups of 7, so we had 2 groups come out. And then here we have 1 group of 7, so it's just h. Here we're using a calculator. So the 6th root, we're going to hit the 6 button first because it's the 6th root. The math key right underneath the alpha. We're going to go down to number 5. And we put in our 112. And that gives us approximately 2.19. Now, if we're rounding to the nearest hundredth, maybe we would say, we'd go to our tenths, hundredths, thousandth spot, and that would actually round up. So if we're rounding to the nearest hundredth, like the directions request, it might be best to call that 2.20. Now, since we're using calculators, we couldn't break this down. We couldn't get the decimal version just by hand. So we're going to say negative 356 raised to the, and if your calculator is going to show this as a real exponent and not just the caret key, which is right above the division, that's called a caret, it does the exponent. I don't need to use parentheses because mine's a full exponent. If yours shows the caret key, then you need parentheses around it. If you're not getting negative 26.15, then you need parentheses around your exponent. So we're going to have 1 divided. We want the negative 17 in parentheses, and we want that to have an exponent of 3 divided by 5. So that's approximately going to equal -0.18, rounding to the nearest hundredth. Tenths, then hundredths. This is 3. One way we can get rid of it is to do a cubed root. So the cubed root needs to be done to both sides. If these are the same, which was the whole reason for using the cubed root, then we have x plus 2. The cubed root of 216. Let's see if there is a cubed root. There it is. It's going to be 6. Now it's not plus or minus because this is an odd number. It's just 6 times 6 times 6 makes 216. Not -6 times -6 times -6. That gives you a -216. So there's only one answer, and your final x value is 4. Here we add 7, which is -2, x to the 5th equals 66. Would have been really nice if that was 64. So that's -33. So now we're going to do the 5th root of x to the 5th and the 5th root of -33. Now, because it's an odd number, the 5, the index is an odd number, we're looking for 5 of a kind, we can do that to a negative number. You cannot take the square root of a negative, but you can take any odd root of a negative. So we plug in the number 5, hit math, down to number 5, and plug in our -33. We get -2.01. It's an approximate value because it's rounded. Even though we didn't change any numbers by rounding, we did drop off all the other values. Here we divide by 2. One thing that we can do if you have x cubed, of course you could take the cubed root. You could also raise that to the reciprocal, the 1/3 power. And you take the 125 to the 1/3 power. That's another way to calculate it and not use radical symbols. So 3 times 1/3 gives you x to the 1st power. And we already know that the cube root of 125 is 5. Because it's an odd exponent, the denominator is odd, we know that it's not plus or minus. We add 5 to this. So we get 27.03. We're going to divide both sides by 3. So we get x minus 6 to the 4th power. 3 goes into 7 twice. There's 1 left over. 3 goes into 12 4 times. Doesn't go into 0 and goes into 3 once. So So we can take our x minus 6 to the 4th power. We can raise that to the 1/4. That means we're going to take 2,401 to the 1/4. Now we have to remember that this is an even number. Crosses out. So we get x minus 6. And the 4th root. So 2401 raised to the 1/4 is going to be 7. That's going to be a plus or minus 7. So we're going to have x minus 6 equals 7, which when we add 6 to it, we get the answer of 13. We're also going to have x minus 6 equals negative 7. And when we add 6 to it, we get negative 1. And in both situations, when we plug it in here, we plug in the 13 and it gives us a negative 7 raised to the 4th power. That gave us the 2406. Times that by 3, add 5 to it, and we're up at 7,198. Same thing with negative 1. Negative 1 minus 6 gives us negative 7 to the 4th power times 3 minus 5. You can check that work. Going to that 8 times, going to that 2 times, going to that 3 times. Working out pretty well. We're doing the 6th root of x to the 6th. We're doing the 6th root of 823. This is the 6th root, so we hit the 6. We go to the math button, scroll down to number 5. And now we're going to put in our 823. That gives us a value of 3.06. So x is approximately 3.06. Now that has to be a plus or minus because this is an even number. So our last example. We have the volume of a beach ball can be approximated by using this formula, where r is the radius. We're going to estimate what the radius would be if the volume is 600. So we have 600 equals 4/3 pi r cubed. We can multiply 3 to both sides. That would eliminate the 3 in the denominator. That would give us 1,800. Then we can divide by 4 pi. That gives us r cubed. Now we need to be careful about this. Because when we take 1,800 and we divide that by 4 pi, the 4 pi has to be in parentheses. So that's 143.24. That's an approximated answer. Now, what you need to be careful is that you didn't say 1,800 divided by 4 pi. because that divides 1800 by 4, then it times it by pi. That's not what we want. We want to divide by both the 4 and the pi. So then we're going to do the cubed root of our 143.24 and the cubed root of r cubed. To do that, I wouldn't take the cube root of your decimal quite like that. We want our 143 as our real answer, and we're going to take math down to number 4, which is the cubed root, and we want to do that to the entire answer. The answer button, the ANS button, is with the negative key. So the cubed root of your previous answer, that gives us 5.23. So this is going to be 5.23 inches is going to be your radius. That is still an approximated answer. Good luck, everybody.